So the last chi-square test. There's one more chi-square test, and it's for homogeneity. Homogeneity. Sometimes it's called homogeneity of proportions. Sometimes it's called homogeneity of populations. It really is just about homogeneity. So, well, we'll have time. We will have plenty of time. Yeah, I don't think this is going to take us all block. Okay. So just a test for homogeneity. Okay. Okay, ready? Everyone ready? Ready? Okay. All right. So chi-square test for homogeneity. We talked about homogeneity. What does the word homogeneity mean? Likeness, sameness, anything that's the same. For lack of a better term, sameness, likeness. Um, anything that's homogeneous share a specific trait, right? Whatever that trait is. Anything that's we call homogeneous is they share that. Okay. Okay. So, what is a chi-square test for homogeneity? Talk about. Well, it compares two or more populations. So you can do two populations, you can do multiple populations or treatments on the basis of a categorical variable to see whether the categorical proportions in one population are equal to the same category populations in another. So it just, you can have that thing about tests for homogeneity, you can test multiple populations. You can test two populations. If you were only going to test two populations, I would just use a two sample proportions test. But for homogeneity, you can test 3, 4, 5, 6, 7 populations to see if they're homogeneous in a specific way. Okay. Okay, so our null hypothesis is going to be there's no difference in the distribution of categorical variables for several populations or treatment. Okay, so I'm going to highlight this part and this part. We got to put those in context. Okay, so we're not going to put the highlighted parts. We're going to put context for those. Same thing with the bottom. There is a difference of a categorical variable for several populations or treatments. Okay, so the highlighted part is the part we need to change for context purposes. Okay. Degrees of freedom, same as yesterday, right? Rows -1, columns -1, multiply them together. Okay. Chi-square statistics is the same for all chi-square. Chi-square, anytime you're doing a chi-square test, chi-square statistic is always going to be the same. And you don't have to memorize it because it's the very last thing on the back of your formula sheet. Okay. You just have to do it for each cell, right? Like we did yesterday. Expected counts are exactly the same as yesterday. Okay. So we did row total times column total, and we divided that by grand total. That's how we came up with each cell, the expected counts in each cell. That's what we did. We did that for each of them. Okay. That's what we're going to do today. All right. So the thing about homogeneity is it's very, 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 very similar to what we did yesterday. For test for independence association, the question is just different. Okay, but it's pretty much the same. Okay, so here we go. Example: do high school students in Michigan and California have the same music preferences? Okay, we used the census at school website to select separate random samples of 100 high school students from Michigan and 100 high school students in California. Students were asked, what is your favorite music genre? The two-way table summarizes their responses. Okay. Do these data provide convincing evidence at the 5% level that the distributions of favorite music genre differ for high school students in Michigan and in California. Okay, so who are the populations? There you go, high school students in Michigan, high school students in California, right? The sample is those 100, but the population is all high school students in Michigan, all high school students in California, okay? So they're testing to see if students in Michigan and California have the same music preference. That's what the other variable is. Okay, they're testing to see, hey, are these numbers here the same as these numbers here? Obviously, they're not the same. Anyone can see they're not the same. None of them are the same. Some are close. Some are off a little bit. This one's off by 8. This one's off by 1. But we're looking for significantly different, okay? Because our null hypothesis is going to be there is no difference. And if we can reject that, then we're going to say there is a difference, okay? So that's the prompt there. All right. So first thing we're going to do, we got to do our, just like we always have done. But since we've done calculations first before, let's just do calculations first again. You don't have to, but since we've done that before, we'll do calculations first there. Okay. So the first thing we need before we can actually calculate chi-square, because that's what essentially what we need to do, we have to use, we have to find expected counts. Okay. So expected counts for each cell. How many cells, first of all, how many cells do we have? I didn't highlight that. How many cells do we have here that we have to take account of? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The rest are totals. Those don't count. Those are just totals. Okay, the rest are either the words, which we don't, doesn't apply with the data, and then totals. Okay, so there are 10 cells. Okay, each of them has to have, those blue ones are those are the expected, or the observed. That was what actually happened. There were actually 12 students in Michigan who said their favorite music was country. There's actually 22 students in California who said their favorite genre of music was rap. Okay. Okay, so for the first one here. So here's the thing. You can make a different table or you can write it side by side. It doesn't matter. If they don't give you enough room, I would write it another table. So I haven't done that yet, so I'll show you how to do that. It's not very hard. So we have Michigan, we have California, we have country, we have pop, we have rap, we have rock, and then other. Okay, so we want to label this. This is the observed. This is the expected. So it's kind of like your calculator does, where it creates two separate, you have matrix A and matrix B. Okay. Okay. So the first one we want to calculate is country. Let's start with country. Country, Michigan first. Okay. So country row total is 16. Country Michigan column total is 100. So we're going to go 16 times 100 divided by grand total, which is always 200. And you get 8. Okay, so the expected, I would expect 8 students out of the 100 in Michigan to prefer country. Okay. Here's the thing about the totals. The totals will be the same. So that's a kind of a quick way to do it, the table. If you just do one side, you can add up and figure out the rest. So that means in California country will have to be 8 as well because they have to equal 16. The totals are always the same because it's the same number of students. It's just expected. Okay? So we can go pop. Now we can say pop in Michigan first. So pop in Michigan is 29 times 100 divided by 200, and we get 14.5. Okay, so if in Michigan there's 14.5 pop, the rest have to come from California. So it's going to be 14.5 as well.
Isn't it just going to be the same because the column rule is the same?
Mm-hmm. Exactly. So wrap is 43 row total times 100 divided by 200. You get 21.5 and 21.5. Rock, 17 times 100. 8.5. Other.
47.5.
All right, 47.5. So when we add down, we should get 100 in each column. We should get 100 in each column. When we add side to side, we should get the number that was already there. So I have a question. Why are the two, why are California and Michigan always the same in each category? Okay, so the formula is the same. Okay, but why else? Exactly. This test is homogeneity. Now, if two populations were homogeneous, wouldn't it make sense that they're exactly the same? That's why. Okay. Okay, so now we have our our 10 cells. Okay. So chi-square says take the observed. So I'm going to do Michigan country first. Michigan country. So we got 12 minus 8 squared divided by 8. I'm going to do, you can go down, you can do Michigan pop next, or you can do California country. It doesn't matter because we have to calculate them all, but it does not matter which one you do. So I'll do California country. So that's 4 minus 8 squared divided by 8. And then we're going to continue along that process till we get to the last one. So if I continue in that process, my last one will be California other. So that's going to be 50 minus 47.5 squared over 50. No, not 50, 47.5. Okay. Shortcut. We're going to use a calculator to do the rest. Okay. You don't need a calculator, but it is faster to do it this way. Okay, so when we do chi-square tests that are not goodness of fit, so independence or association or homogeneity, we're going to use matrices. Remember, matrices for two-way tables. Okay, so to get to the matrix button, hit the matrix button. To edit them, you got to actually go to edit, just like you do with a list. And then you want to say how big you want it. Well, this one is 2 columns by 5 rows, so 5 by 2. Oops. Okay, so we're only going to put observed. Only make one list for observed, or one table for observed. So I got 12, 4, 15, 14. right? All 10 cells are there. So now we're going to go over to stat tests. We're going to go down. Remember, there's two chi-squareds. There's a goodness of fit, GOF, and then there's another. We want the other. I don't want goodness of fit because this is not a goodness of fit test. So expected should just always be B. Remember, don't worry about expected. It'll calculate expected on its own. That's another way to find out expected using the calculator. Okay, calculate, draw, don't matter. So our chi-square statistic is going to be 4.850. Chi-square statistic. And then our p-value, because it's calculations, right? P-value, we also have to find 0.03030.
How do you change the list for observed?
How do you what?
So like when you're at the chi test the chi test, right?
Mm-hmm.
How do you change it to the right matrix? No, I mean like you're in stat test, right? And then you go to the thing.
Let's see. It should always be A, B.
Mine is on C and D.
Just hit clear and then go second matrix and should put it in.
Just change it to A.
Let's see. No, matrix.
Yeah, if you just hit clear and then go second matrix, it should let you put it in.
Oh, there you go. Yeah, you're right.
Okay. Yeah, I don't think I've ever changed mine. They've always been A and B. I don't know. Okay, you got it? All right. Okay. So we got our calculations. So now we got to kind of backtrack to figure out what we missed. Okay. All right. Population parameter. We have two populations. We talked about that, right? We have PM and PC. Or P1 and P2, as long as you label what P1 and P2 are. So we're going to say true what? I would do it the other way. True distribution of proportions. True distribution of proportions for Michigan students what? Favorite choice of music, yeah. Favorite type of music, favorite choice of music, favorite genre of music, whatever you want to. Choice of music. And then it's going to be exactly the same for California students, but just California instead of. Yep. All right. Null hypothesis. We go straight up to the first page. The null hypothesis, the first part, the parts I did not highlight are you're just going to literally cut and paste. So there is no difference in the distribution of there is no difference in the distribution of yeah, there's no difference in the distribution of proportions or music genres for students in Michigan and California. There's no difference in their distribution of proportions. Okay. There's no difference in the distribution of proportions for students. I forgot, big chunk for students. Favorite music. Michigan and California. Okay. Hypotheses, that's the null. Alternative, there is a difference in the distribution of proportions for students. Okay. There is a difference. Okay. Significance, they told us 5%. All right, conditions, assumptions, SRS. What do we put there? They stated that what? What was random? What was an SRS?
The sample was in there.
Okay, sample of what?
100 high school students.
There you go. The sample of high school students they got. That's what I'm looking for.
No,
Okay.
right.
No, I'm just looking to see if we know who or what they're looking for. Okay. Expected counts. All expected counts above 5. Yes, they are. 10 out of 10. Done. We don't need to since the second one passed. The third one obviously would pass too. Now, if the second one fails, I definitely want you to do the third one. Okay, so we did a couple test statistics. We did this test statistic first.
We still need the degrees of freedom.
We're going to use degrees of freedom in a second here. Okay, that's the big one that we use, chi-square for each of the 10. And we added them all together. Okay. So we kind of use shortcuts, but one thing that's important. There are 10 of these guys, 10 fractions all added together, right? That make this number. It's not just one of them that makes this number. It's all 10 of them. But each one is a chi-square. Each one is considered a chi-square statistic. The total is there. Okay, that's important to note. Okay, and then degrees of freedom, just like yesterday, row -1, column -1. So on today's, we would have 1, 2, 3, 4. 4 degrees of freedom. Okay. And last part, conclusion. Since p-value, which was 0.3030, is greater than alpha level, which is 0.05, we fail to reject the null hypothesis. Okay? Therefore, we lack significant or sufficient evidence to show or to suggest that alternative in context, there is a difference in the distribution of proportions, that there is a difference in the distribution of proportions for of students' music choice in Michigan and California. So we don't have enough information to say there is a difference, even though there is a difference. If you go and look at the table, there's a difference. There were 12 students who liked country in Michigan, 12 out of 100. There were 4 out of 100 in California that liked country music. There is a difference. There is a difference, but it's not significant enough. There's a difference here. 15 in Michigan like pop music. 14 out of 14%, I should say. These are all percentages or decimals. Right? Okay. So there is a difference in the sample, but it's not big enough so that we can say there's a legit difference in music taste between all students from California and Michigan. Okay. Here's another question. They didn't ask this question, but they will. Which cell or which test statistic had the biggest chi-square or had the most influence on chi-square? Chi-square is right here. Chi-square is right here. So which cell or which test statistic, because each one of these is a test statistic, had the biggest influence or had the most amount of say in chi-square? How do we know? What do we look for? There you go. We're looking for the biggest number out of all 10 of these guys. So the biggest difference, let's see. The difference here is 12 and 8. That's 4. The biggest difference here is 4 and 8. That's 4. Here and here, that's half. Same thing here. Here and here is half as well for rap. Rock has a little bit of difference, but that's 1.5. Other is 2.5. So the biggest chi-square was country. Country for both. Okay? Country for both. It was the one that was the furthest away from what was expected. Okay? They'll ask that question, especially if you reject. If you reject the claim, they'll especially ask that question. Okay? If you don't reject, they probably won't ask that question because there wasn't enough to reject. But, okay. All right. Okay, so last